Hi, welcome to this video. In this video lecture, I will go through projectile on an inclined plane, okay? And we will find the time of flight and the range of that projectile. Also, I will give uh, I will give a prompt to ChatGPT and show you how to actually give the prompt to ChatGPT so that it will give the correct answer, okay? So our question is, a ball is thrown with an initial velocity of 10 meter per second at an angle of 60 degree above the horizontal. The ground is sloping downward with an inclination of 30 degree. Find the time of flight and range of the projectile. So that is the question, okay. It is saying that the ground is sloping downward with an inclination of 30 degree, okay. So let's see the image, okay. This is the image. So this is the initial velocity vector and it is making an angle of 60 degree with the horizontal, and the ground is actually sloped down with an angle of 30 degree, okay. And this will be the path of the projectile, okay. It is not our usual projectile motion, okay. So what you can if you compare it with the actual projectile or normal projectile motion where land is horizontal, you know that the in that case what will happen. In that case, time of flight will be less than this case, or you could say that in this case range is the along and distance travel along the inclination will be more than the normal case, and the time of flight will be also be more than the usual or normal case, okay. Okay, here key difference is ground is inclined and range and time of flight will be more, okay. And the range is the distance traveled along the horizontal, okay. So to solve this problem, we should resolve motion along two axes parallel to the inclined ground and perpendicular to it, okay. We should always not just in this question, always when you're solving this kind of problems, always resolve perpendicular, parallel and perpendicular axis. Why we are doing it? Because when one motion is perpendicular to other, that both motions will be independent of each other, okay. So we can actually treat them independently and find the solution, okay. So this is our graph by with resolving. So this is our, we could say that our positive x-axis which is along the inclination, and this is our y-axis which is, or vertical axis which is perpendicular to the inclination, okay. So what will be the velocity along the incline? This is the velocity v. Then velocity along the incline will be v, this angle plus this angle, so it will be v cos 90 and it will be 0, okay. Initial velocity, okay, that's what I am talking about. And velocity perpendicular to the inclination, inclined ground will be v sin 90. Sin 90 is 1, so velocity will be v and v is 10 meter per second, okay. And there will be acceleration, okay. There is an acceleration acting downward in this direction. What did I do? I this is the total acceleration g. I resolved into two components. One is this component, one is this component along the inclination and perpendicular to the inclination, okay. Along the inclination will be g cos 60 and perpendicular will be g sin 60, okay. So when this is 30 degree, this will be 60 degree, this will be 60 degree. That's how we arrived that 60 this will be a 60 degree, okay. So what is velocity? Perpendicular velocity at a time t, it will be, we can use the relation v equal to u plus at, okay. U is here v sin 90 and a is actually v perpendicular. V perpendicular is in that case acceleration is downward opposite to the initial velocity. That's why we are using minus, and it is g sin 60 into t, where t is the time, okay, time, okay, at which the perpendicular velocity we have to find, okay. And the horizontal velocity will be u is v cos 90, velocity along the inclination v cos 90, and g is actually in the same in the positive direction, okay, right, like this. So plus g cos 60 into t, okay. So what mistakes that might students do? Okay, actually one mistake is, common mistake is resolving velocity along and velocity along perpendicular and parallel to the horizontal instead of taking perpendicular and parallel to the ground, inclined ground. Okay, and also one other mistake students make is not considering acceleration along the inclined ground. Okay, in normal projectile motion, the acceleration in the horizontal direction is actually zero. There is only a g. So by habit, what happens is students actually forget to take the acceleration along the inclined ground. Okay, that is g cos 60. Students actually forget to take the g cos 60 component. Okay, so this is again our image. Okay, so this is our v perpendicular that we already arrived. We got the equation. Okay, so how to solve this? To solving this, when we are thinking about the motion, when it is coming here, when the our ball reaches here, the vertical means, or perpendicular to the inclined plane, that displacement will be zero. Okay, so in usual thinking you will say that yeah, it has a displacement like this much amount. No, we are our axis is this is our axis. Okay, this is our axis. Now this is our uh, horizontal. Now this is our what we are only thinking about this line. Okay, to us this line is straight. Okay, so in that case the ball is here, it is at a zero level, and a ball, when ball is here, it is also at a zero level. So at a at the finish of the projectile motion, the vertical or perpendicular displacement will be zero. Okay, we will consider that condition in order to find the solution. Okay, so we have the relation s equal to ut plus half a t square. It can also only be used when acceleration is constant, that you all know. Okay, here s equal to 0, so we are applying the condition when the ball reaches here, the perpendicular displacement s is here, s is 0, and what is u is the initial velocity perpendicular, initial perpendicular velocity, that is v sin 90. Sin 90 is 1 and v is 10 given in the question, so 10 into 1, so it will be 10 meter per second. Okay, and the acceleration, this is the acceleration component, that is actually opposite to the velocity, so we will take it as minus, so it is minus g sin 60, that is minus 10 into root 3 by 2. Sin 60 is root 3 by 2, so it will get a minus 5 into root 3 meter per second square. Okay, so we plug in the value 0 equal to 10t, so s is 0, so that is why 0 equal to ut, that is 10t, half a t square, half a is minus 5 into root 3 t square. Okay, so this second term as a negative, so we can take it to the left side, or we can take the 10t into the left side and cancel the negative on both the sides. Okay, so I took the 10t to the left side, and there will be minus, and this also minus, we take cancel both the minus, so we will get 10t equal to this value. Okay, and you can cancel t. Okay, so when we cancel t, we will get a t as 2.31 seconds. That means the time it takes for the ball to travel this much distance is 2.31 seconds. So what is this 2.31 seconds? That is actually time of flight. Okay, so time of flight is 2.31 seconds. Okay, now we have to find the range. What is range? Distance travel along the inclined ground in time of flight. Okay, so again we have s equal to ut plus half a t square equation. Okay, here s is the one we have to find, and u is v cos 90. Okay, here cos 90, right? V is cos 90, so cos 90 is 0, so we will get initial velocity along the inclination is 0. Okay, and acceleration is actually here positive along the incline, which is d cos 60, so 10 into 1 by 2, which will be 5 meter per second square. Okay, so we got a time of flight as 2.31 seconds. So in we will substitute all these values. Okay, so s equal to ut plus half t square, so u is 0, 0 into 2.31, half is 0.5, a is 5 meter per second square, t is again 2.31. so when we substitute, we will get a value as s equal to 30.34 meter. So the range along the inclination is 13.34 meter. Okay, and the time of flight is 2.31. Okay, so what I also did was I plugged the questions straight to the ChatGPT and observed whether the ChatGPT gives the right answer. So same question, right? No change. Okay, without changing any definition of angles, I gave it straight to the ChatGPT. Okay, as a new conversation, and let's see what happens. So when we plug the question straight to the ChatGPT, we know that effective angle is actually 90 degree, that we know now, but they took it as theta minus alpha, 60 minus 30 degree. So ChatGPT using 30 degree as the angle, effective angle, and solving the question. So they they got the wrong answer, right? So they got the final answer of 1.18 and range as 10.2 meter. Okay, so that was a mistake, because we have to define the angle very well for ChatGPT to give the answer correctly. Okay, also if you even if you upload the image, ChatGPT might make a mistake, so it is always better to explain the image using words. Okay, so in the next slide, I have given the a prompt so that the ChatGPT won't get confused about the angle. So in this, what did I do is, a ball is thrown with an initial velocity of 10 meter per second at an angle 60 degree above the horizontal, and also said that it is counterclockwise from the horizontal. In the next line, the ground is inclined downward 30 degree below the horizontal, and give the clarification that a clockwise from the horizontal. Find the time of flight and range of the projectile. Also clarified that range is actually defined as the distance along the sloped ground. So in this way, ChatGPT won't make a mistake. Okay. So let's see what effective angle this time they are getting, or ChatGPT is getting. So it is actually 90 degrees, so it is getting correct answer, correct angle. Okay, and resolving as we did. Okay, so it got the time of flight as 2.35. Okay, we got 2.31 because we used a g as 10 meter per second. Okay, it used g 9.81. So I again gave a prompt like take g as 10 meter per second square. Okay, this time ChatGPT get the same answer as our answer. Okay, okay, so it got the time of flight as 2.31 and range as. Okay, so that's how we can give the correct prompt to the ChatGPT. Okay, so I am giving a task. Okay, give me the condition how to find the maximum height. Okay, what condition we should use to find the maximum height. Okay, and also what is the time taken to reach the maximum height. Okay, so I will be uploading more challenging questions like this, and also how to give prompt to ChatGPT to get the correct answer. Okay, if you like the video, please subscribe and comment. Okay, thank you.